Dear students and viewers, let us continue the previous classes on chemistry. In the last session, we discussed about the atomic number, mass number, how to find the valency of the elements, and also we found how to find the valency of a group like a phosphate group, like sulfate and carbonate, etc. Then we take a simple chemical reaction and we saw the chemical reaction between the reactants which are trying to form some products. And we have taken the example of acids reacting with the base to form salt and water. So these are the videos which we have covered in the last two videos. Today let us discuss more about the bonding, how the elements try to combine with each other to form products, to form new products or new compounds. Okay, and what is the type of bonding exists between them. Okay, so today we are going to see about chemical bonding, or we can tell is bonds. What are different types of bonds available? Bond is nothing but how they are binded, how they are combined together. Okay, so there are three types of bonds. One is called as ionic bond. The second one is covalent bond. The third one is coordinate covalent bond. The fourth one is van der Waals forces. So these are the different types of chemical bonding. So let us try to today cover the ionic bond and the covalent bond to the maximum, and if time permits we will try to move with the coordinate covalent bond. So let us take what is meant by ionic bond. And the first question, what is the question which will rise to your mind is that why they have to undergo a bond? Because they want to attain the stable octet arrangement, because all other elements are interested to become like what? Helium, neon, argon, krypton, xenon and radon. So all other elements, whatever we have seen, yesterday we have seen there are nearly only 18 elements. Apart from these 6 elements, all other elements will try to attain the stable configuration like these rare gases or the inert gases. Okay, so only they are undergoing the chemical bonding or the chemical reaction. So let us today try about the case called as ionic bond. The name itself indicates it's ion. The bond is formed because of forming of an ion, whether it's going to be a cation or an anion. So if a cation is going to combine with an anion, a new product will be formed. So the main thing which is lying behind the ionic bond is the formation of ions. So generally the atoms or elements will be in the neutral state, but we have to first of all convert the atoms or elements into the ionic state. Then the bond between the ions will result in a new product forming the ionic bond, So the theory maybe we will not be able to appreciate much, but what we can see means we will take an example and see how the new products are formed. We'll be interested to know that. Now let us see how the sodium chloride is formed. Formation of sodium chloride. And what are the bond which exists between this sodium and chlorine? Is a very good example for our ionic bond. Is a very good example for the ionic bond. Okay, now what is the atomic number of sodium? 11. Okay, very good. What is the atomic number of chlorine? 17. So if I am going to draw the diagram, you can see. So what is the number of protons in sodium? 11. The neutrons is, instead of 11 it is 12. It is what? 12 because the mass number is 23. So if I am going to add these two things, we will get 23. So in the first orbit, how many electrons will be there? 2 electrons. 2 electrons. In the second orbit? 8 electrons. So I am not drawing, okay, 5, 6, 7, 8. So it is 2, 8. So in the third orbit, how many electrons will be there? Only 1 electron. 1 electron. So now the sodium want to become a stable configuration like neon. What it has to do? It has to give you one electron or it has to gain 7 electrons. For instead of gaining 7 electrons, it's easier to leave 1 electron. Now let us come to the case of chlorine. Now let us come to the case of chlorine. The chlorine, the number of protons is 17. The number of neutrons, let it be 18. Okay. Then let us have the first cell, it will have 2 electrons. The second cell, it will have 8 electrons. Okay, sorry, I will try it in this one. So it will be having 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8 electrons. So 2 here, here 8. So in the third orbit, how many electrons will be there? Yeah, because totally 17. So 2, 8 and 7. So I am indicating the electrons of chlorine with the dot and indicating the electrons of sodium with the cross symbols. So 4, 5, 6, 7. So it is 7. Now, if the chlorine want to become like argon, argon's atomic number is 18 because it will be 288. If the chlorine want to attain similar to the state of argon, how many electrons it need? 1 electron. Or the other case, the different case is what? It has to leave the 7 electrons. Instead of leaving the 7 electrons, it is better to gain 1 electron. So now we can see the sodium is ready to give 1 electron to become like a neon, and the chlorine is ready to accept 1 electron to become like argon. So both can attain octet arrangement, but the case is different. The sodium is ready to give electron and the chlorine is ready to accept an electron. Now, let us, I hope you got the logic. So if this 1 electron from sodium is transferred to chlorine, it will become what? Like neon. This chlorine will become like what? Argon. That's fine. Now, let us consider the case of sodium alone. Let us consider the case of what? Sodium. It is proton is 11, neutron is 12, and 2, it is 8, is 1. Now, this is electron. Whether this electron will be attracted by this proton or not, yes, surely it will be attracted. Let us take the sodium. Definitely this electron is attracted by this proton because proton is positive charge, electron is negative charge, opposite charges attract each other. So if I want to remove this electron, whether the electron will be removed easily? No, definitely this electron will not be removed easily. I have to supply external energy to remove this electron from this sodium atom. Even though the sodium is ready to give the electron, but simply it not give. Because this electron is having affectionate with this proton because they are opposite charges. So this proton will be attract the electron. This proton will be attracting the electron. So definitely we have to spend some energy to remove this electron from the sodium atom. Okay. So this energy is called what? This energy is called what? I want to supply some energy. For what you are supplying the energy? To remove the 1 electron. When you are removing 1 electron, what will happen to the sodium atom? When I remove 1 electron, after removing, what will happen to the sodium atom? I do not know about reduction or oxidation. What this atom will become?
Neon.
It will become a configuration similar to neon. That's fine. I am asking about sodium only. I want to compare with neon. The intention is to become like neon. I agree. Yeah. Now the neutral atom becomes ion. The neutral atom becomes what? Ion. So the energy what you are supplying is called as ionization energy. The energy what you are supplying is called as what? Ionization energy. So I will repeat once again. Now we want to remove this electron to make its electronic configuration similar to neon so that it becomes stable. So what I am telling means this electron can be removed without supplying energy from the external source. Now the energy is required to supply from the external source to remove this electron so that this atom will become ion is known as ionization energy. Is known as what? Ionization energy. So the energy what I am supplying is called as ionization energy or ionization potential. Both the same. Ionization energy, I will write it here. Ionization energy or ionization potential. So I am going to give the ionization energy. So when I am going to give, sodium will become what? Sodium will become Na plus 1 electron. Sodium will become what? Na plus plus 1 electron. How it came? Now you listen here. Here in the left hand side, here there are 11 positive charge and 11 negative charge. 11 protons and 11 electrons. So what is the charge? Total charge? Neutral. So the sodium atom. But when I remove one electron, there are 11 positive charge and 10 negative charge only because I removed one electron. So how many positive charge is there? So that positive charge only I am writing here. That positive charge only I am writing here. So the sodium becomes sodium plus ion by removing an electron. By removing an electron. For this we have to supply energy from the outside. This energy is called as ionization energy. But the sodium will be ready to give this electron even when lesser amount of energy is given. Why? Because it's ready to give an electron to become octet like neon. To octet like neon. Got the logic? So the ionization energy for sodium will be lesser. Compared, whenever I'm telling lesser, it's a compared degree. Compared, I will tell later. Compared to chlorine. Compared to what? Chlorine. So if I want to remove an electron from sodium, it is easier. Easier means what? It's enough to give only lesser energy to remove the electron from sodium. Whereas, if I want to remove one electron from chlorine, you have to supply a lot amount of energy. It's very difficult. Okay, that is called what? Ionization energy for chlorine will be higher. Will be what? Higher. So it's only a comparative term. It's only a comparative term. I will repeat once again. Now sodium, we have 2 electrons in the first orbit, 8 electrons in the second orbit, and 1 electron in the third orbit. If this 1 electron is removed, it will attain the stable configuration like neon. But this electron is negative charge, this proton is positive charge, so I can't remove it easily. I have to supply energy from the outside source to make the atom into ion. So this energy is called as ionization energy or ionization potential. When I am going to give this energy, this electron will be removed from the sodium atom. So the Na will become what? Na plus. I hope I given the reason already. So we move on to chlorine now. Okay, fine. Now you see this, the electron which is given by sodium, if we can take it to chlorine, now this electron has been removed from what? Sodium. So Na becomes what? Na plus. Now this electron if we are going to add to chlorine, the sound will become what? 8. So it will become octet arrangement. It's very easy. But once, I hope I am fast, but I hope you can able to understand. Okay, so when this electron is from the sodium is removed and added to chlorine, instead of 7 it becomes what? 8. So let us write the chemical reaction. So Cl, when is going to absorb 1 electron given by sodium atom. Given by what? Sodium atom. So what will become now? Cl minus. Okay. Na by giving some ionization energy will become what? Na plus 1 electron. This 1 electron is being absorbed by what? Chlorine. So it becomes Cl minus. So what is chlorine earlier? 17 protons, 17 electrons. So what is the charge? 0. Here, after absorbing electron, it becomes Cl minus. Why? Because there are 17 protons and 18 electrons. So 17 positive and 18 negative. So there will be 1 negative. That 1 negative is shown here. So the chlorine becomes what? Anion. The chlorine becomes what? Chlorine anion. Here the sodium becomes sodium cation. Sodium becomes what? Sodium cation. Cation means I already told. T is looking like positive charge. The symbol is looking like positive. So ion means charged particle. So positive charged particle. So it's sodium cation. This is chlorine anion. Now, when I'm going to add an electron to the chlorine, whether chlorine will be happy or will be worrying. I am going to add one electron to the chlorine. So whether the chlorine will be happy or worrying? Happy. So it releases energy. There in order to remove an electron, we have to supply energy. But when you are going to add an electron to the chlorine, it will be happy. Why it is happy? Because it's going to attain the outer element like argon. So it will be happy. So this energy is called as electron affinity. Electron affinity. What is electron affinity? Affinity means interest. So this chlorine having affinity towards electron. Why? If it's going to gain one electron, it becomes stable like argon. So when this electron is added, it will release energy. It's exothermic. It will release, this chlorine atom will release energy. So that is called what? Electron affinity. Now, students, I will ask a question. Instead of adding an electron to chlorine atom, even though it's not a, now we are completed, but even then I want to ask a question. Instead of adding one electron to the chlorine atom, I want to remove an electron from chlorine atom. What the energy is called as?
So ionization.
Ionization energy. So I want to make this chlorine atom to remove an electron from this atom. So this energy is called what? Ionization energy. Whether this chlorine is ready to give away the electron? No. We have to supply more amount of energy as compared to sodium. Sodium will be completely ready to give the electron. But chlorine, it needs only one electron to become what? Stable. At the time, whether it will be able to lose one electron? No. So the ionization energy of chlorine will be very, very high. Whereas electron effect will be, it will be happy to give energy when it's going to gain one electron. Now there's a bond between the positive charged cation and negative charged anion, which are nothing but the bond between the ions. Is called as ionic bond. Is called as what? Ionic bond. Now I will write it now. The simple reaction. I will write in only 3 stages. The sodium, by giving ionization energy, it becomes sodium cation plus an electron. The chlorine, by absorbing this electron, becomes what? Chlorine anion. This is electron affinity. The bond which exists between these two, Na plus Cl minus, will become what? NaCl. Now what is the charge of NaCl? Neutral, there is no charge because this is positive, this is negative, they cancel. So sodium chloride. So the bond which exists between sodium and chlorine is called as ionic bond. Let us continue the covalent bond in the next class.